Hello, my name is Edward Chen. I'm an adjunct professor in the CS department of Stanford University. My presentation title today is examining GPT4's capabilities, and then we propose enhancements using our method called SocraSynth. First of all, we all understand the knowledge breadth and the depth represented by the LLM, large language models. But it's less well known about the representation of the knowledge, which we say is kind of polydisciplinary, and we will explain what is polydisciplinary shortly. And because of this very rich representation, an ordinary user like myself is not able to formulate good questions to get profound answers. And finally, we can talk about some advanced topics which we are undertaking currently. And there's no doubt about the breadth and depth of LLM's knowledge because of, for example, GPT-4 and the Google system, they pretty much include all the documents they can get a hold of on the internet. So we don't have to debate on this subject. But the key thing is, like I mentioned in the beginning, polydisciplinary representation. What is that? So oftentimes, when we study in a college, right, we only study one discipline, maybe two. But when we say interdisciplinary means a person has multiple disciplines in himself or herself, rather than saying, when we want to work on a research, we have 3 PhD students to work together, each come from one discipline. And this is also well understood. But what is polydisciplinary? Polydisciplinary is like GPT. Remember how GPT was trained. GPT was trained, the optimization function is to append the next word, and that's it. And whatever documents we input to GPT, including, let's say, articles from psychology, articles from architecture, engineering, and so on and so forth, GPT has no notion whatsoever about the categories or disciplines of the article. So therefore, it doesn't have this kind of knowledge boundary, put everything together into this kind of black hole. So its representation, again, has no discipline boundary whatsoever. And if I ask a question today, which is perhaps a question belong to physics, and GPT wouldn't say, oh, this is a category A kind of question, I'm going to also only gain to the subset of my knowledge. No, it's going to just go to this entire kind of polydisciplinary infrastructure representation to get solution or answers. So the representation itself to us is really unknown. And the synthesis out of this representation can produce a lot of unknowns, which means we don't know even we don't know. Okay, and this is very, very critical going forward. And this is one example in one of our early articles. We ask GPT, we say, okay, now we have these 2 GPT agents. One is called GPT-A, GPT-2, GPT-B is the other. And we say, can you conduct a discussion on the subject of Adam and Eve? And we like to encourage you to explore some unknowns. And so on the left-hand side was our prompt. Then, surprisingly, after a few rounds of discussions, and they expand the discussion topics from just one ancient story, ancient tale, into multiple perspectives, including ecological narratives, AI and philosophy, and neuroscience and the selfhood. I just give you one simple example. And in the first round, GPT-B saying, well, are there other cultures, other stories similar to Adam and Eve's story? And one of GPT agents saying, yeah, Pandora box is one example from ancient Greek, I believe. And the notion of you don't open it, there's something forbidden. And if you trespass, then a bad thing will happen. And then at the end, they say, well, human beings right now in the world, we sort of like conducting a lot of non-desirable behavior to pollute our environment. So in a sense, we are committing some forbidden actions or not desirable actions. And the ecology of the earth is getting worse and worse. We are going to lose the earth, or metaphorically, we are going to lose Eden. So it's very intriguing. They can kind of connecting to different perspectives and different notions, and even deep in ecology, AI, and neuroscience. And the details is documented in our one of our papers. And then we come to thinking about another interesting feature is represented by GPT-4. And this paper is well known, published by the Microsoft people working with OpenAI. And two particular things we can talk about. One is the performance of GPT-4 is superior to other models, right? This is one of their benchmark published in that paper. And you can see GPT-4 on this important MMLU data set. They have much higher score than the previous models. And of course, this week, Google just launched their new system called Gemini. So I would say Gemini or GPT-4, they are probably on par. Okay, so we don't have to get into the details of this. And today is more important in the insights to the foundation models. And this picture is also documented in the Microsoft paper I just mentioned. And the most stunning outcome is this red rectangle I circle here. So what does this mean? This actually shows three colors of representations. And the yellow color, the blue color is just using GPT 3.5. And they OpenAI trained two additional models. One is GPT-4 without vision, without imagery information. And the other one is GPT-4 with image. So GPT-4 with image is darker green, and GPT-4 without vision is light green. And if you look at this column, this is GRE quantitative. So basically GRE math with images with vision. GRE quantitative could be outscored using GPT-4 with vision over GPT-4 with about 17% to 18%. And this is quite stunning because most of the GRE quantitative questions, if you look at the GRE exams, they don't have pictures. So without imagery data, but when you do training, you include vision data, can outperform GPT-4 without vision data. And this is a situation we still cannot explain. So, but this means there's some new representation, and when question was asked, GPT was able to synthesize based on those kind of representation, come up with some novel solutions. Okay, so this is a summary picture of what we have learned. So we know in this world, most of things are like we don't know. So we know something we know something maybe we don't know. If we don't know something, we know we don't know something, we ask questions. But the final red rectangle area is perhaps the most important to advance our knowledge. If somehow we don't know we know, that's something called intuition. But the majority of things in the world is we don't know, and we like to be able to use SocraSynth to export it. So this is an example of, they saying, every year we have this Nobel Prize ceremony, and the existing or the past award winners will be sitting in the podium, and the new winner awardees will come up to give a speech. Suppose we have just a 10 years old kid to come up and try to ask questions just in front of the panel. He has no idea how to even formulate a question to get some insights from this Nobel laureate. And this is precise what our condition is in front of current LLM. We must concede, right, with this multi-model and the interdisciplinary, even polydisciplinary representation. And LLM is much, much more knowledge than us. And oftentimes we ask a very simple question without precise contextual information, then we blame the LLM to be hallucination. So we say, wow, very stupid. But actually, in my opinion, it's all about how to ask right questions. Stupid. This is kind of a Clinton slogan. And we just cannot formulate seriously and insightful questions. And then how do we solve this problem? The SocraSynth model is a pioneer model to try to model artificial consciousness to address the issue. So the 5 features I mentioned in the beginning, I'm going to just continue the presentation. At the end, we can summarize how we accomplish all those. We know critical thinking is important, and Socrates 2,000 years ago proposed using Socratic method, we can conduct critical thinking. And the process, as Socrates said, I don't know anything, so how can I understand a new issue? Is by me asking good questions and with my students, right? Like a PhD advisor and I may not know the details of student research. And I ask students what you are doing, what are the methodologies, and I can provide advice. And in the situation of this GPT, we are not as smart as Socrates. So if we say, I am Socrates, I'm going to ask question with my student doing interaction, well, that's reasonable because Socrates is very knowledgeable, knows how to ask question at least. But a 10 years child, no way he or she can ask good questions. So therefore, the spirit of Socrates is, okay, this 10 years old child like myself, we are not going to pose question. We are becoming the moderator. We ask Socrates and his student Plato, they can have a dialogue, right? I only pose a subject matter. And then I ask them to polarize their stance. One is supporting, one is opposing the subject matter. For example, abortion should be legalized or abortion should be banned. One is for, the other one is against. Then they do their debate, and the debate run after run, though more insights will be discovered. So this is a picture, architecture picture of SocraSynth. A moderator kind of arbitrate this meeting, and the moderator is not going to give opinions on the subject matter. The moderator only saying, okay, now you have two agents, and agent A, agent B, one is the proponent, the other one is the opponent of the subject matter. In the first round, as we will depict shortly, we asked two agents to formulate the subtopics they want to debate. And this is an optional step, but our experience, if you can identify subtopics of the subject matter, the debate can be more engaging rather than you have a quiet opening debate cannot converge. And then the moderator pretty much just sit back to seeing the debate going on and going on. And at the end, if the debate is sort of converging, means the moderator can ask both agents saying, do you have more arguments to make, or are you ready to make concluding remarks? And the agent can say yes or no. And the moderator can say, okay, if you are ready, start making concluding remarks. And you see judges sitting on the side, which they are going to evaluate this debate, the quality and the validity, credibility, and so on and so forth. And this is the second phase we call evaluative phase. Okay, so let's look into how to formulate debate. We have three phases: generative, evaluative, and finally collaborative. And generative, as I said, we have moderator. For example, we use this subject matter, should AI be regulated? And we have one agent who is a proponent, and in this example, use GPT-4, and opponent is also using GPT-4. And initially, we set the debate's contentious to be high. Contentious is a very important parameter. And one of the novelty of this work is this contentious parameter, and I will discuss in detail shortly. So in the first iteration, and the moderator asked both agents to come up with subtopics. As I just mentioned in the beginning, this will be helpful for having an engaging debate. So in the beginning, you look at agent A and agent B. Their subtopics are not really corresponding to each other really well. So after a couple of rounds, they come up with 6 or actually 5 subtopics. And every subtopic, you can read in the paper for details, are much more engaging. Every subtopic, one, for example, the first one, agent A, concerned with the ethical integrity of data privacy, and agent B is worried about the innovation will be kind of stalled and stifled. And likewise, and the second topic, agent A considered to be data privacy is very important, and agent B considered this could be a barrier of entrance for some small university or small countries because preserving privacy can be costly. Okay, so once they have come up with subtopics, then you just continue to start debating for a number of iterations. And at the end, they enter the conclusions situation and the debate ends. So as I said, contentiousness is a very important parameter. And it's a big surprise to us when we use a different level of contentiousness, and GPT-4 actually performs or behaves differently in the aspect of their tone, emphasis, and the language. The two agents will employ different tones, different emphasis or languages to try to support their own stance. And the details, please look in the paper, but this is quite surprising to us because we thought when we trained GPT-4 was like only appending the next word. But for some reason, GPT-4 was able to kind of model attitude and model emotion, which was our another different work. Okay. So the different degree of adversary, different degree of contentiousness, and GPT-4 would behave differently. So when contentiousness is extremely high, like 1.0, two agents are not going to rational debate with each other. They just label each other and just curse each other, cancel each other. This is like a lot of political situation we observe today. And if it's 0.7, 0.9, the debate will be heated. And there's a big advantage of heated debate because they are forced to come out of the default biases inherited from the training data. If I ask two agents, one to be supportive, one to be opposition, and they are forced to be polarized to be positive and negative, and that indirectly free them up from their default biases. It seems counterproductive, but think about it very carefully. And that's a trick. We can free the agents from the inherited biases from the training data. Okay. So because of time limitation, I'm not going to go into too much details, but the paper documents, then they move into the closing remarks and evaluation. We have other robots doing this evaluation process. The method we used is called the Socratic method, and the algorithm is called CRIT, critical reading template. And this is documented in another paper. If you are interested, you can read that. And this is a picture of Socratic method developed by Socrates, and each template is mapped with inductive, deductive, or adaptive reasoning. And then we can use subroutines to conduct our evaluation. And this is the CRIT algorithm documented in the paper. And after evaluation, it's really kind of encouraging. And we use DaVinci 003, GPT 3.5, and GPT-4 itself to kind of evaluate the debate quality of two agents. And the scores are quite consistent. In this particular case, they all score agent A as a winner, even with changing the kind of order of debate, and the scores are still to be the same. So that means that the judging criteria or the judging process seems to be reasonable. Okay, so when you lower down the collaborative kind of contentions to be very low, and the two agents will be very kind of cooperation with each other. So at the end of very heated debate, like this was one paper I published, but later I took it down because some controversy in the department. And this paper was wonderful. At the end, I said, don't just be contentious saying yes or no. Do you have any proposals for the UN to resolve the situation in the Middle East? And I think the resolution at the end, the proposals are quite moving. So I just released this paper again after a month of self-censorship. If you're interested, you can take a look. So let's get into the conclusion. We have applied SocraSynth in multiple applications, and all the papers are listed under SocraSynth.com. And again, the spirit is we just human being has limited knowledge. We cannot really ask good questions. So therefore, we kind of formulate a dialogue between LLMs. And we remove hallucination because you see that in the debate process, the contextual information is getting richer and richer. So in the process of improving context, the answers from another opponent can only be more precise. And also in probability, one agent will never make the same hallucination twice. This is just like we have bad dreams, but we never dream the same bad dreams twice. And therefore, in statistics, if you don't repeat your bad dreams and you are not going to affirm your bad dream, and in the debate scenario, you'll be refuted very quickly. And in contentious very high, participants will attempt to discover new insights. And this is going to tap into, we call unknown, the polydisciplinary kind of potential knowledge pool. Okay. So for bias, I already mentioned, we polarize the two agents. So therefore, they actually freed up from their inherited the biases. And we look at the results, they are very reasonable because at the end, they are forced to be polarized. But when we lower down the contentiousness value, they will be resolving their different stances at the end. And in the future, we are going to focus on identifying and understand unknown unknowns. That's definitely a very interesting area to tap into unknown knowledge to do information discovery. And all our papers is under SocraSynth. And thank you so much for your attention.